All right, so we had a question about this copper problem here. We have a 95.9 gram piece of copper heated up, and then we're transferring it to some water, and the water heats up in the process of being in contact with the warm copper. And they want you to calculate what the initial temperature of the copper metal is. Okay, so I drew out this scenario. Okay. Beforehand, we have the hot piece of copper. I drew it like a block. We have it in the cooler water. And all of the excess heat of the copper is going to transfer to the water until they're the same temperature. They're both warm. 22.2. That's not like super warm, but I'm just going to be calling that warm. All right, and the heat transfer stops between the metal and the water once they're all the same temperature. So how much heat did the copper give to the water is one thing we'll have to answer before we can actually solve for the temperature. All right, so the first thing we're going to do is we're going to solve for the amount of heat absorbed by the water. And for that, we need the equation Q equals mc delta T. And I'm just going to write that with respect to water. H2O, H2O, H2O. All right, so let's just plug and chug these values. We have 400.0 grams of water. We're going to multiply that by the specific heat of the water. 4.184 joules over grams degrees Celsius. And then we're going to need the change in temperature of the water. Okay, let's do that on the side somewhere. Delta T H2O, we need the final minus the initial. And let's see, we're going to have 22.2 minus 20.7. All right. It's not one of those days I can do simple math in my head. So let's see. All right, 1.5. Yeah, maybe I could have done that in my head. All right, so we're going to have 1.5 degrees C as our change in temperature. Always do final minus initial, even if it gives you a negative number. Okay, then you won't get into negative sign. You won't get into, sign issues. All right, so 400 times 4.184 times 1.5. And we get 2,510.4. What's our units? Well, grams cancel. Degrees Celsius cancel, leaving us with just joules. And that's good because we wanted a heat. Okay. 4 sig figs, 4 sig figs, 2 sig figs. We'll see how sensitive the homework is about sig figs, but I'm just going to underline 25 for now to remind ourselves we have 2 sig figs. And this number, I'll just carry the extra digits because I don't feel like writing in scientific notation or anything. And we'll reduce rounding error that way. Okay, so this is the amount of heat that the water absorbed from the cube cooling down in the water. Okay, the amount of heat absorbed by the water is the same amount of heat that the copper gave away. Okay, if I give you $100, I have negative $100. You have positive $100. Okay. So the $100 bill I gave you is the $100 bill, but since I lost the money, in order to make 100 equal to negative 100, if we're doing money, you need a negative sign on one of the sides. Okay. So it doesn't matter which side. I could have put it there. Doesn't matter. But the Q of something, the Q of anything is equal to the negative Q of its surroundings. Okay. So we can just rearrange this. We're going to have Q of Cu is equal to negative Q H2O. So negative 2,510.4 joules. Okay, this is the amount of heat lost Okay, wording is annoying. You say the positive number is heat lost. So this is the heat gain. I don't like that word. Heat change. Let's use the word heat change. Okay. But the copper lost 250 10. That's why we have a negative number. Heat change of copper. Okay. So we're getting a little bit closer. Let's go to a new sheet. All right. So let's see. So we have QCU equals MCU, C of CU, delta TCU. We have to do some algebraic rearrangements. Okay. I'll do it, but I encourage you to maybe pause here and try it on your own first, just to get that algebra exercise. We're going to try to isolate the T initial for the copper. We're going to try to isolate that variable. Okay, give that a shot. I'll be doing it here myself. All right, switch sides. Delta T, CU, MCU, CCU equals QCU. Delta TCU equals QCU over MCU, CCU. Delta T is TF minus T initial. And we need to isolate Ti by itself. So I'm going to have, I'm going to switch these terms around, switch sides. I don't like it when you switch sides and you end up having to switch sides again. I'm sure there's a way to anticipate that. Okay, so I'm going to throw this term there, and then I'm going to throw this term over there. When you move sides, you have to change the sign. So we're going to have Ti equal to Tf minus QCU over MCU, CCU. All right. And now we can finally plug and chug for the initial temperature of the copper. Okay, we're talking about copper. All right, the final temperature of the whole system was 22.2. Degrees C minus the Q of the copper. Oh, check this out. We have a negative number, but we have a negative sign here. So negative in front of negative, that's going to turn into a positive. I love it when that happens. 2510.4 joules. Okay. All right. And then I'm going to do something sneaky here. Okay. I don't want to give away the direct answer, so I'm going to change the number on you. Let's do 99.9 grams. Okay. I'm not going to do all the work for you. Okay. Just most of it here. Help you out. So I'm going to put 99.9 grams of Cu. I'll just make a little note. I changed this. Josh changed this. Okay, the number I got was 95.9, and I don't remember if Aktiv randomizes that number or not, so I'm not taking a chance. Okay, and then the specific heat of copper was 0.38. Joules over grams, degrees Celsius. Okay, so we can see unit-wise, joules will cancel, grams will cancel. 1 over degrees Celsius will leave us with a degree Celsius in the numerator. So I'll just move it to the numerator immediately. All right. 22.2 plus 2510. Let's make sure I'm still on the screen. Yep. 0.4, 2 sig figs here. Tell you what, I'm going to deal with this separately first, just for making sure my sig figs are good. So 2510.4 divided by open parentheses 99.9 times 0.380 close parentheses. So we get a 66 here. 0.1 degrees C. So 22 plus 66, we'd get 88.3 degrees C. Okay. And that would be what I would type into Aktiv. Okay, for sig figs. Oh, what happened? For sig figs, my guess would be that it'd want the answer just to the ones place because I showed the reasons why. But in case it was accidentally like unsensitive, maybe you would try it to 1 decimal place. Okay. But again, I changed the number for the grams of copper so that I wasn't giving away the answer directly. Okay. So the main takeaways there was to make sure you're solving for the correct variable, the initial temperature, and to recognize that in the math, you had to have the negative Q value for solving for the copper. You cannot use the positive. And you'd get a weird answer too. Like going back to the work, you can see that ended with a hot temperature here, and that makes sense. If you had done your math wrong, like you didn't have the negative Q plugged in, you probably would have got like a lower temperature or something, which doesn't make sense. The metal was hot in the first place. All right, hope this helps. Let me know if you have any questions. Take care.